And welcome back to section 10.2, where we'll be going over some problems involving radicals. So the first question is simply going to ask you to take an expression that's written without a radical and to write it with a radical. And we'll go ahead and see what that looks like. So let's take a look at a few simple ones here. We'll start with number 9. This is problem 9 for the textbook in section 10.2. This is x to the 1 over 6. So we're trying to figure out how we write this as a radical. We're going to look simply at example 1 where we have a to the 1 over n. In this case, the a is serving as the x, and instead of 1 over n, it's 1 over 6. So we're going to go ahead and put the x under the radical, and it's going to be the 6th root of x, just like we showed in example 1 there. If we have another one, and we're going to go ahead, so we're going to go ahead and write that there. Then they're asking us also if we can go ahead and simplify it, if we could do so. So let's take a look at another such problem here. Going to number 11. I'm given 16 to the 1/2. So another way to think about 16 to the 1/2 is simply the square root of 1/2. Now I could write this here as the square root of 16. I could put the 2 here, but if there's no number here, we assume that it's just the square root. So I could just write that more simply as the square root of 16. And its equivalent value, therefore, is equal to 4. Let's take a look at another such problem that we could hopefully simplify without too much difficulty. That's going to be 8 to the 1/3. Well, another way to write 8 to the 1/3 is putting the 8 under the radical, putting the cube root symbol here. And the cube root of 8, hopefully you know that 2 times 2 times 2 is equal to 8. So that is going to be equal to 2. So they ask us if we can simplify it. Go ahead and simplify it. And if we can't, because there are variables involved, then we just write it with a radical expression. So we're going to go, or radical notation, I should say. Let's go ahead and take a look at some that might get a little trickier. And by the way, all these properties involved rewriting it as we did in number 1. Take a look at 17 now. This is going to be the quantity of x, y, z raised to the 1/2. Well, if I want to write that in radical form, I'm just going to go ahead. I'm not going to put the 2 here because it's understood to be there. And I'm going to write that as the square root of x, y, and z. You can put the parentheses there if you want to. It is not necessary to do so, though. Let's take a look at some that get potentially a little trickier. Number 19. We have a to the 2nd, b to the 2nd, and this is raised to the 1/5. Okay, so we have some information that has an exponent. Well, nothing to really simplify here. We're going to go ahead and just take the 5th root, which we get from here, of a to the 2nd, b to the 2nd. And as I mentioned before, we can't simplify, go any further with it, so we're not going to bother. Another one we're going to begin to go to is we're going to begin to look at how we use property number 2. That is, when we have something where it's the, maybe 81 to the 3/4 or something like that. So let's say I have, for example, 21. I have t written to the 2/5. So now we're looking at property 2. We want to see, is there a way we can write this using radical notation? So it's going to be the 5th root, because that's where you get the number from. And we're going to write this as t squared underneath. So the root at the bottom is going to get written on the outside, and the square is going to come along with the t and get written in the following way. Let's take a look now at question 23. We have 16 to the 3/4 exponent. So you could, if you wanted to, write this as the 4th root of 16 to the 3rd. That is one way you could rewrite it, and you may be asked on my math lab to show this as a first step to doing this question. However, it's not a necessary step to solving the problem, not if you use the notation that I'm prescribing for this. So what I recommended earlier in the previous notes is to go ahead and take 16 to the 3/4 and write it as 16 to the 1/4 times 3/1. So 1/4 times 3/1 is simply another way of writing 16 to the 3/4, because if I take 1 times 3, that's 3. 4 times 1 is 4. Well, what it allows me to do, it allows me to break this up into 2 steps now. So if I take 16 to the 1/4, that's going to be 2. Well, 3/1 is simply equal to 3. So now if I take 2 to the third, that's going to equal 8. So 16 raised to the 3/4 exponent is now equal to 8. So this is one way in which we can simplify it. Let's take a look at some other problems. I'm going to continue to leave the key on the side as I mentioned I would before. So going forward, let's take a look at some problems where maybe the value in the top of the rational expression is bigger than the one that's seen at the bottom. And this is actually not 27, it's going to be 25. And this is going to be 27 to the 4/3. Again, I'm going to split this up into two parts, or at least split this exponent up into two parts, and write this as 27 to the 1/3 times 4/1. When I do that, I can go ahead and get the cube root of 27, which is equal to 3. And I'm going to write 3 to the 4/1, or just 3 to the 4th. And 3 to the 4th is going to equal 81. For those of you who aren't real strong at exponents, remember 3 to the 4th is just 3 written out, 4 times and multiplied together in that way. So that will now give us the value of 81. One last problem that we're going to go ahead and take a look at is question number 28. And that's going to be 125 times a written to the 3/2. Now, sometimes these things can be simplified and sometimes they cannot. So, for example, we can't take a square root of 8. So, this is going to get stuck under the radical. So, this is where a time it might actually help to use radical notation. So, it's going to be 125. Sorry, this is not 125 to the 3/2. This is 125 to the 2/3. This is going to be 125 to the 2/3. So it's going to be a cube root of then 125a, this quantity squared. So it's going to be 125a, this quantity squared. So, well, first off, we can take the cube root of 125. That has a cube root. So I can write that now as 5 times the cube root of a squared. And that's as far as we can really simplify. One other thing. This 5 here is going to be a squared 5 because it's not like we can totally ignore this. So I'm going to think I'll probably just try to start this one again and explain it a little better. I think there's so here's one thing we can do. I'm going to take advantage of not only this property here, but I'm going to take advantage of this property here. And what I'm going to do is I'm going to distribute the 2/3 to 125, and I'm also going to distribute the 2/3 to a. Now, a to the 2/3 I really can't do a whole lot with other than put it under a radical. So it's going to be the cube root of a squared. However, okay, so what I did is I just took the value of a, which I really can't simplify more than this, and wrote it as such. But 125 to the 2/3 I can write as 125 to the 1/3 times 2/1. So the cube root of 125 is equal to 5, and then 5 squared, that's equal to 25. So this is going to be 25. This is going to be the cube root of a squared. So the best I can do with this one is write it as 25 times the cube root of a squared. Not exactly the neatest presentation, but it is a tricky question, so be prepared for this one. We'll go ahead and do one more and see if we can clean up the presentation of this a little bit. Let's go ahead now to question number 30. I'm going to use this stapler here to keep the weight down. So question 30 is going to be 9y to the 6 to the 3/2. So like I did in the previous problem, I'm going to use this property here to simplify everything, but I'm also going to use this property to distribute the exponent on the outside here. So I have 9 to the 3/2 times y to the 6th to the 6 times 3/2. So here's what I'm doing. I'm distributing this to 9. I'm distributing this to y to the 6th. But now I have to basically use, when I multiply y to the 6th to the 3/2, I'm using now property number 3, where I multiply the exponents together. So it gets a little tricky. So let's go ahead and simplify this first. Well, I can write this y to the 6 as 6/1. So it's going to be 6 over 1 times 3 over 2. Well, 6 over 3, that's going to equal 18. 1 times 2 is 2, so that's going to be 9. So we have y to the 9th here. So y to the 6th raised to the 3 halves is equal to y to the 9th. 9 to the 3 halves, on the other hand, I can write as 9 to the 1 half times 3 over 1. Well, 9 to the 1 half, that's equal to 3. 3 to the 3rd is equal to 27. So this is 27. This is altogether y to the 9th. So we got 27 y to the 9th for our final answer to this. So this is how we take expressions that are written with rational exponents and work to try to simplify them a little bit. So now we're going to begin to take this the other way. And we're going to take a look at expressions that are under radicals and write them with rational exponents. So now we're going to take problems that are written under radicals and work to write them with rational exponents. Let's take a look at a few examples here. Question 31. We have the cube root of 20. Well, to write it with a rational exponent, we're just going to go ahead. 20 has no exponent, so we're going to say that's going to be 1. So we're kind of working backwards from this to here. So this is going to be written as 20 to the 1 over 3. We have another question like 34, where it just appears to be the square root of 6. Remember, in this problem, it's assumed that this is a 2 here, so I'd write this as 6 to the 1 half. Again, this is just going backwards from rule 1 up here, going from here to this form with a rational number in the exponent place. Let's take a look at 38 now. Here we have the 5th root of n to the 4th. So this is kind of working backwards from rule number 2 in the top. And I'm going to go ahead and write this as n to the, let's see, n goes here. That's going to be n to the 4 fifths. So I take the 5th root of n to the 4th and write it as n to the 4 fifths. If I have something like 42, where I have something a little more complicated, where it looks like the 7th root of x to the 3rd, y to the 2nd, z to the 2nd, I can go ahead and write this. I'm going to take this quantity on the inside here and write this as x to the 3rd, y to the 2nd, z to the 2nd, and I'll write that to the exponent of 1 over 7. Now, you'll see here, since everything has a different exponent, I take the whole quantity of what's on the inside here, and I put it in a parentheses on the outside. And I make sure that everything is written to the root of 1 over 7. So, essentially, the radical here functions like the parentheses do here, because it's this entire quantity that is raised to the 1/7 exponent, or it's the 7th root of it. Okay, let's go forward now. This work is not terribly hard. It is a little tricky. Let's take a look just at one last question in that particular part. That's going to be 48. So we have the expression 3a divided by the 5th root of c to the 2nd. So all we're going to do in this part here is we're going to leave the top the same. And we're going to go ahead and apply rule number 2. Go backwards from this. We're going to write this as 3a over c to the 2 fifths. And that's it for that section. So right now what we're going to begin to do is to take a look at some expressions that we're going to begin to try to simplify a bit. And we're going to take a look at ones that particularly contain negative exponents. So we're going to be taking a look at this rule a little bit, bearing in mind that one of the things that we have to do is to get rid of the negative exponents and simplify what we can. The rational expressions just complicates this work a little bit. So let's begin to look at question number 50. 50, we begin with 10,000. That's written to the negative 1 over 4. So the first thing we want to do is we want to get rid of the negative exponent. So remember, if you want to do that, you got to put a 1 over it and put it in the denominator. So let me just put a 1 under to start. Now we're going to switch spots. So this is going to be 1 over 10,000 to the 1/4. So hopefully you know that 10,000 to the 1/4, or the 4th root of 10,000, is going to be 10. Just check your work. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. So we can write this now as 1 over 10. And that's going to be our final answer to that problem. Let's take a look at something we're going to kind of simplify a little bit just by rewriting the expression we have in question 52, where this is the quantity of 5xy to the negative 5 over 6. All we're going to do with this one is we want to get rid of the negative exponent. There's not much more we could really do with this one other than that. Once I flip it to get rid of the negative on the exponent, I'm going to write this as 1 over 5xy, maintaining the parentheses, to the positive 5 over 6. So because we have no 6th root of 5, and we have no 6th root of y, and 6th root of x, and so on, I can't simplify that much further. When it's just numbers, we can do some extra work with it. Let's take a look at 54, something a little trickier. So this is going to be 1 over 8, and it's going to be the negative 2 over 3. So if you have a fraction in parentheses like this, and the whole thing is raised to a negative exponent, all we're going to do is take the reciprocal, or flip the fraction. So we're going to write this now as 8 over 1 to the 2 over 3. Or, removing the 1, we just write this as 8 to the 2 thirds. So if I write 8 to the 2 thirds, I'll go ahead and write this here again. If I have 8 to the 2 over 3, I can write this now as 8 to the 1/3 times 2 over 1. And 8 to the 1/3 is equal to 2. And if I write 2 squared, that's all going to equal, not 2, all going to equal 4. And for question 54, that should be my final answer. So sometimes in problems like this work begins to get a little complicated. Sometimes we have to move things, and sometimes we don't. Let's begin to take a look at 56 to see what that work is going to look like. We have the expression 3b over a to the minus 5 over 7. Okay, so when I began to work with this kind of lesson, I ask people often who's ever had the experience of moving. And the reason I ask that is because there's something that we have to do when we move. When we move, we have to box things. And in this case, anything that has a negative exponent is something that we are going to box. So it's a rule that you're going to hear me refer to, because when you get fractions that get a little fairly complicated and robust, there are some things that have to get moved and then some things that don't. Now, as it turns out, the whole denominator is a to the minus 5 over 7. So we're going to move the denominator entirely, but we're going to leave 3b at the top. So I can write this as 3b. I'm going to move a to the negative 5 over 7 and make that a to the 5 over 7 on the top. But if we're going to really write this in more proper form, we probably need to have the a written first to have it as 3a to the 5 over 7 times b. Not a huge deal. I wouldn't take off for a test, but I can't swear that my math lab won't ding you for it. So just something to be careful about when you do this. Now, I could put this over 1 because 1 always remains, but at this point, if it's over 1, we can just get rid of it. So, all right, let's go ahead to a few other questions that kind of reinforce this idea. We're going to take a look now at 58. So in 58, we have 2ab to the negative 1/2 times c to the 2/3. Well, since I know negative exponents are going to be involved, I know fractions are going to be involved. So what's going to happen here is I'm going to go ahead and I'm going to put this over 1. And again, I'm going to keep the premise in mind that I box what I move. Keep this in mind. I box what I move. What gets moved? Things with negative exponents. So I'm going to box b to the negative 1/2. So whatever the negative exponent is attached to, that's what I box. So when I rewrite the top here, I'm going to go leave the 2 in the same place, the a in the same place, the c to the 2/3 in the same place. But when I move b to the negative 1/2 to the bottom, I'm going to write it as b to the 1/2, and I'm done. That is now as simplified as I can write that. So right now it's just kind of a big moving game where we have all these negative things floating around. We're trying to figure out how best to simplify it. We're going to take a look at a few more problems that deal with this, and we'll go from there. So take a look at 60. This is going to be 2 to the negative 1 over 3 times x to the 4th times y to the negative 2 over 7. If you wanted to try this question to see what you do, you can go ahead and stop the video now. Just bear in mind as you do this, box what you move. And if you want to continue listening, then we're going to do the following. I'm going to go ahead and put that over one like I've been telling you to, and I'm going to box what I'm moving. So I'm boxing these two items. That means that x to the 4th is going to remain on top. I'm going to move 2 to the negative 1/3 and y to the negative 2/7. Down below as 2 to the 1/3 and then y to the 2/7. And that's it. So if you can keep that rule in mind to box what you move, this is not a terribly difficult thing, but it's something you should get comfortable with. One more item here. So take a look at 62. So now we've got 7x over 8yz, all raised to the negative 3 over 5. So in this last question here, remember, it's like we said before in one of the previous problems. If you have an entire fraction and the entire thing is raised to a negative exponent, all I'm going to do is go ahead and flip the fraction. And then change the exponent from negative to positive. So it's going to be 8yz over 7x to the positive 3/5. And that is the only thing I can do to work toward simplifying this. Okay, so we've applied some of these rules for exponents here. I've kept these rules to the side. I'm going to keep going with some more questions where we're going to use the law of exponents to simplify, but now we're going to begin to work with the properties of adding and subtracting fractions. So if you're not comfortable with fractions, you're probably not going to be too keen on this section. Let's take a look now at 78. So we have 11 to the 2 over 2/3 times 11 to the 1/2. So we all know the rules that if we have something like this is like rule 1, where we have to add the exponents. So this is going to be 11 to the 2/3 plus 1/2. Now, yes, this means we have to add exponents, and they have unlike denominators, and we've done a lot of work with this lately. So hopefully most of you know that if I have something like this, I need to multiply the top and bottom of this by 2, the top and bottom of this by 3. So I'm going to get, for this, it's going to be 11 to the 4 over 6 plus 3 over 6, or 11 to the 7 over 6. And no one is looking for you to take the 6 through to 11 and take the 7th exponent of whatever that root is. They just want this in simplest, form with the rational exponent here. Okay, and let's take a look at another such example. Let's take a look at number 80 now. If we have 8 to the 7/11 divided by 8 to the negative 2 over 11. Okay, so there are a couple ways that you could do this. You could use rule 2. So we're going to do this a couple different ways. One way is to use the second rule. So I could write this as 8 to the 7 over 11. So minus, what am I subtracting? Well, the exponent down here is negative 2 over 11. And as most of you probably know, if I have two negatives here, I can do this as 8 to the 7 over 11 plus 2 over 11 and get 8 to the 9 over 11. So I can use the property I have here for the laws of exponents, take the difference of these, and because this is negative, I realize I have to add. Another technique for this is to go ahead, and so that's one way. If you want to write the problem again, go ahead. I'm going to use the same problem though. I'm going to box this, and I'm just going to move this up, so I have 8 to the 7 over 11 times 8 to the 2 over 11. Because I moved to the top now, it's going to become positive. So now I'm going to use rule 1, where I simply add the exponents to get 8 to the 7 over 11 plus 2 over 11, giving me 8 to the 9 over 11. Same answer, no matter how you do it. And there are a lot of problems working with exponents because the properties are consistent and so fluid that we can get away with doing a lot of this type of work. Okay, so we're going to go ahead and do one more problem using this property, and then we're going to apply a few different properties as well. So let's go ahead and take a look at 84. We have, in this one, 5 to the 5/4 to the 3/7. So we have 5 raised to the 5/4 raised to the 3/7. Well, if we look at here, if you have something that's raised to an exponent with an exponent outside, we multiply the exponents. So this is going to work out to be 5 to the 5/4 times 3/7. And nothing simplifies at all nicely here. So 5 times 3 is going to give us 5 to the 15/28. And again, we're just trying to get something in simplified form with the exponent. So it's 5 to the 15/28. Let's take a look at another problem here, where we have question 88. This is going to be 27 to the -2/3 times 3/2. Okay, so probably the best way to handle this type of question, we could try to get rid of the negative radical first. But let's just go ahead and see if we can multiply these together. So we're going to take advantage of the property 3 here and see if we can simplify this a little bit. So I can write this now as 27 to the -2/3 times 3/2. And if you're following along, this is 2 times 3 is equal to 6. 3 times 2 is equal to 6. Well, this is all going to give me 27 to the -1. Well, I need to express my final answer without a negative. So when that point, now I can go ahead and flip this and make this 1/27. And I now have my answer in simplest form. So we're going to take a look at just one other problem with a little twist to it. And that's going to be question number 90. So this is going to be here, x to the -1/3 times y to the 2/5. And that's all going to be raised to the 1/4. So really what we're going to be doing is we're taking a look at properties 3 and 4, because we're going to be multiplying each exponent on the inside by the exponent on the outside, and we're also going to distribute that exponent across both terms. So looking at utilizing properties 3 and 4 here. So this is going to be x to the -1/3 times 1/4 times the quantity of y raised to the 2/5 times 1/4. After that, this is going to give me x to the -1/12 times y, and let's see, 2 times 1 is 2, 5 times 4 is 20. Well, 2/20 simplifies to 1/10, so I'll just write that here. But now if I put this as my final answer, I have something negative here. So what I'm going to do is I'm going to take this, put it over 1. I'm boxing this, and I'm going to move it below, so I have y to the 1/10 over x to the positive 1/12. And this is how my final answer for this type of question should be expressed. Okay, we have one more set of questions to go through. We're going to start with problems that are embedded in radicals. We're going to convert them to rational expressions. And then when we're done converting them to simplifying them as much as we can, whether written with rational exponents, we're then going to convert them back in simplest radical form. So this part gets a little tricky. You may need to watch this a couple times to make sense of this. That's fine. You know, you watch this as many times as you want. So let's take a look at 92. This is going to be the 6th root of e to the 2nd. So what we're going to do here is we're going to write this in with a rational exponent. So it's going to be a to the 2/6. And if you observe this, you can say, well, yeah, 2/6, I can rewrite this as simply a to the 1/3. All I do is just simplify this in simplest form. And then when I am done putting this into simplest form. This exponent here, this rational exponent, I'm now going to go ahead and convert it back with a radical. So this is going to be the third root of a. So I've taken this, written it as a rational exponent, simplify the rational exponent, and then convert it back to an expression containing a radical. So we'll go ahead and do some more examples to clarify this a little better. Let's take a look at 94. 94, we have the cube root of x to the 15th. I'm going to go ahead and write this with a rational exponent. So this would be x to the 15 over 3. Well, if you look at that, you say, well, 15 divided by 3, that's simply just x to the 5th. Well, nothing else you could do with that. No radical is necessary for this. So we won't bother putting a radical with it. So let's take a look now at 96. Here we have the 10th root of t to the 6th. Let's go ahead and convert this and write it as a t with a rational exponent. T to the 6 over 10, which I can simplify by taking 6 and 10 and dividing it by 2. So I write this as t to the 3/5. And now I can write this with the radical again, saying that this is going to be the 5th root of t to the 3rd. And that is as much as I can simplify that with. Okay, let's continue on with question number 98. We have the cube root of AB, this whole quantity to the 15th. So, again, we're going to kind of treat this radical like it was underneath here, or this exponent like it's underneath here. And we're going to write this now as the quantity of AB, because we have two things underneath there. We need to make sure we do that. So, the 15 over 3. So, when we simplify 15 over 3, that's going to be AB to the 5th. And now what I need to do is to follow the property 3 here, or follow property 4, where I distribute the 5 to the A and the B, so I get A to the 5th times B to the 5th. And that's how we simplify the work for question 98. So let's go ahead and see if we can take a look at a few maybe more robust problems. Take a look now at 104. So I can take the 4th root of the square root of x. Now, please don't freak out when you see something like this. I know it's a square root of a square root, but let's just look at it. Okay? So, if I'm taking the square root of something, one way I can write this is I can take the 4th root of x to the 1/2. Okay, so how am I going to write this with as a rational exponent? It's going to be 1/2 as over 4 with the x there. So now, what is one way I can kind of simplify it? So I have half on top. I have a 4 at the bottom. I want to get rid of the 2 here. I don't want a 2 here. I'm just going to go ahead. I'm going to take 1/2 over 4. Let me put 4 over 1. And just like the work we did in Chapter 7, I'm going to multiply by 2, multiply by 2, and that's going to give me 1 over 8. So now I can write this as x to the 1 over 8, or I can write this as the 8th root of x. And yes, I know that notation is a little tricky. And I know that some of you are not going to be terribly happy about that notation. Okay? Please feel free to ask me questions about that in class if that's something you don't like doing or you want further clarification about. Okay, one other question I'm going to have you do is 106, and this will make the last one for the lesson this evening. And that's going to be the square root of the quantity of a, b to the 6th. So in this question here, what's going to help to keep in mind is first, I need to keep a, b. I don't have, it's in parentheses here. I'm going to keep it in parentheses here. But my exponent is going to be 6, and my root here is going to be 2. Not shown here, but let's assume what we put there. Well, 6 divided by 2, that's equal to ab to the 3rd. And keeping the rule in mind for 4, I'm going to write this as a to the 3rd, b to the 3rd. And there we have it. That is our lesson for section 10.2. We will have a lot more fun with radicals in section 10.3. I think the work overall in 10.3 is probably not as tricky as this. This work is not difficult, but it is very tricky to get comfortable with all the different operations that are needed to be performed with radicals. See you later.